Friends, once I asked Claude to code an application for me, and it did a great job. Within minutes, it created a full code, a working code. All test cases were fine. But do you know, the code was broken. It was not broken in a sense that it is not running, but when I saw it have the high memory usage, it was running slow in the database queries. It was firing multiple queries to the database. It is not completely optimized. And this made me realize if I have pushed this code in the production, disaster is certain. So, here we are going to talk about why clean code techniques and data structure become more important in the age of AI, because all the hard work is done by AI, but you need to do the smart work, navigate the AI so that it does the right thing. There is an AI trap, a technical debt speedrun. So before going deep, let's understand what is technical debt. Start with an example. Let's say you want to build some application and you want to Claude or Codex or Gemini, and you start typing some prompts, fancy prompts. Build user authentication system, create REST APIs, maybe create some React components, solve some data structure problem. You give everything and then press button continue. Within seconds, it start generating some output. It start creating more files and doing a lot of work. You are just very fancy things with some lot of fancy names are coming. Yeah, work is done, publifying, fetching, so many things, right? And then you are mesmerized. Wow, AI is doing the work, and now you can sit back and sip a cup of tea. After that, you saw the code is working, but it is not working actually. Why? It is taking a lot of time. It has a lot of loops, inefficient loops running in between. It is pulling the data all together in the memory, which is very memory inefficient. It is writing unnecessary API calls. It is calling database again and again for the same data, ignoring the concurrency issues. These are the hardest thing. Let's take some concrete example. Code generated is like this, and then in this code you see if you have 10 users, then it works fine, there is no issue, right? But if it has 10 million users, then what happens? The complexity, you understand what is on, big on. It is not a very good complexity. This problem could be solved with map, correct? It has o1 complexity for searching. And if there are 10 millions of rows, then you need to load one by one, not every 10 million at one point, right? Otherwise, it will be not memory otherwise it would be not memory efficient. So in this case, this code is working for now. So you move ahead and start doing something else, some extra work, other parts of the project. But this remain as a debt that you need to fix before going to production, or even after production. You will take some time as your customer grows. Maybe you think I will fix it later, but this technical debt start growing slowly. No, it is old time. When it start growing slowly, this is AI era, man, and it grows very very fast. So in the age of AI, data structure become more important. Loops, array, dictionaries, set, tree, graph, red black tree, no matter what you kind of new data structure you bring in, you have to learn all of those. Those are important because AI is doing the very hard work. It is writing code. You are just navigating. You have to become the architect. You have to do that brain work, knowledge work. Techniques of clean code become more important these days. It is now a bridge between the human and the AI. Previously, what used to happen? There is a developer and they are writing code, and other developers might be fixing bugs or adding another feature on top of that code, right? So the clean code techniques works because it helps to understand the code of the other people. Take this example. In this function process, it is doing some processing over the data, and now it is checking with equal to 1, It is having some variables like P and Q. It is checking the value is greater than 100, and you don't know what's happening. As an AI, you will be perplexed. What is happening? What this guy has to do? Even as a human being, I am perplexed what this code is meant. What is the meaning of one? What is 100? What is P and Q? It's very difficult to read and understand the logic. On the other hand, if you read this code, it is written with clean variables. It has every meaning. So one previously become completed when we were checking order total is greater than 100. We are doing some append. So it's just a number. The P and Q are prices and quantities. It gives more meaning, right? When my code was supposed to be reviewed by some senior developers, they often say, your code should be just readable as English. And this is the code that you are seeing right now is just like English. Because if you read the variables properly, you will be able to understand the code. So this is based on the clean code techniques. Even if you are working as a human or some AI is reading this code, they can understand the code very easily. They have some meaningful variables, proper namings. AI generally work very poorly if it has to understand the logic of the your code. So your goal is to make it explicit, and the clean code not just only means the variable name, but you need to give proper code, clean modules, proper hintings, what type of variables it is, explicit interfaces, consistent data models, useful tests that you need to write. All these things will help AI to understand the code and make sense proper. And if there is any bug, they are able to solve and make some sense of the code before even you make sense. And guys, clean code doesn't mean writing comment after every line. Your code should be like a comment where people when read, they are easy to understand. Let's take one more case based on the height of a binary tree. If you see this code is finding the height of a binary tree. It is basically finding the height of left tree and the right tree, and whichever is maximum, adding one. It's a recursion code, right? And what is the time complexity in the space complexity for this? Pause this video and think. It visits every node once, so the time complexity is on, and it is recursive approach, right? So it is using stack for storing the nodes of counter program. It's a recursive code, right? So it is storing some memory for the program counter, and that height or the space will be taken as O of h if h is the height. So in worst case, the tree could be skewed, so the height would be on. So in worst case, height of the tree could be n, right? Because it is skewed. So the memory will be required O of n. But in normal cases, balanced case, it is log of n. Now see this code. This is balanced. It is iterating over the tree, and it is calculating the height. First calculating the height of the left tree and the right tree, and finding a difference between them with absolute difference, checking if it is greater than 1, then it is not a balanced tree, basically false. And if it is less than 1, then it's true. And checking if left tree or right tree or current node is not balanced, basically then returning not balanced, otherwise true. So take a pause and understand this code. This looks clean, right? A very readable code, proper recursion, all the edge cases handled. It is using the hide function perfectly fine. And if you think about the complexity, can you take a guess? For a balanced tree, it will. So for a balanced tree, the height would be, or basically, if the log n would be the height, and then in that case, time complexity would be n log n. But if it is square tree, then what will be the dimensions of tree? Will be basically O of n, and you are running for each node, so n into n for the height. right? Height plus this particular code. Which for the small interview questions, this code will work fine. It will run some of the edge cases. But for a large real world scenario where there's a huge hierarchy, millions of nodes, or there's a syntax tree of a web page, or there's a file system, there are so much challenges can occur with this code. Complexity is huge. Now see another code and then try to identify what is the time complexity and the space complexity for this. If you try to find the height of using this function, then not just height basically is balanced, right? It is finding the height first of the left tree and checking. If it is not balanced, then just return, because you find the signal that a subtree on the left side is not a balanced tree. Similarly, we are checking on the right side. If right side is not a balanced tree, then we are just returning. Right. If it is balanced, then we are going further deeper and then checking the difference of the height. And then if it is not balanced, then -1. Otherwise, just the height. And at the end, we are checking after calling this function is balanced. Get height if balanced root is not equal to 1. And this code returns -1 as a signal. Time complexity for this code was O(n), right? Big O of n, and recursion is O of h. H is considered the height, and for balance tree it will be just log n. For square tree it will be O of n. So it didn't turn magically the height into the complexity into O of n or log of n. So basically we have not run a magically something and which reduces the complexity to log of n, and we are reducing the worst case complexity also just to O of n, and the recursion depth is just O of n, log n, and worst case complexity of height is also log of n. You see the difference. We have slash the time complexity, the space complexity, and even the worst case complexity. And this is perfect code for running in the production, not the previous one. Even though the previous code was also looking as perfect as this on the surface. Now you can understand. If you don't have the understanding of data structure proper, every code which AI generate looks perfect, but it is actually not perfect. You need to guide as an architect. You need to guide as an auditor. AI is just a tool for helping you to do the hard work, but the smart work still remains on you. You are managing and accountable for the production quality, not the AI. As a developer, you can think whether the code has proper complexity or not, whether your code is making the space properly used or not. If your code can be read by a machine or a human and they can understand the business logic very easily, and you need to maintain this code not just today, not just next month, even after years you will be managing the same code. So will you be able, or another engineer will be able to understand the same code and understand the logic behind it? Without fundamentals, both the slow solution and optimized solution will look equally convincing. The role of software engineering is changing very fast. It doesn't now remain just writing and typing the code. Even before, the real job of software engineer was not just writing code, but to understand the requirement, turning those raw requirement into the professional architecture. And then you need to turn that architecture into the actual reality and write code into different modules. High value work was coming from the trade-off. You need to just make some decision. You need to make the decision based on the requirement and what you want to build to, and in the future how will you test it, how will you secure it. All those decisions make you a proper engineer. In the AI era, now the architects and editors are not just the senior engineers. You need to be as a junior engineer want to become and adopt this kind of roles, if not formally, informally. AI can produce a lot of work very fast. It just knows patterns. It knows how to write and do the coding. It just knows patterns. It cannot explain familiar code. It just knows many patterns. It can explain unfamiliar code. It can generate test and documentation. It can make assumptions, misunderstood requirements. and even it can introduce security problems, use outdated APIs, even expose your API keys to the outside world. It can hallucinate and invent something which is not actually the requirement. So your job is not just to accept or reject the answer of the AI, but your job is about finding the reasoning of the code. So whenever AI generate an answer, check what is the space and time complexity, whether the exceptions are handled properly or not, what kind of actual real world challenges can occur. Is it facing any security problems? Is it exposing any important keys or architectural designs to the outside world? Do not think of AI as an autopilot that remove the need of to understand the engineering. Thinking is powerful engine. Think of it as powerful engine. Powerful engine that makes a skill driver faster. It doesn't make driving knowledge unnecessary. You need to know that. You can't outsource your thinking.